G'day all, and welcome back to Unimig. Today we're going to continue on with our Ultimate Guide series, this time covering TIG welding, so let's get started. But first of all, what is TIG welding? Tungsten inert gas welding, otherwise known as TIG welding, is the process in which an arc is formed between a tungsten electrode and the workpiece to join two metals together. The fillet rod is often fed into the weld pool by the operator to create a weld. A shielding gas is also required to protect the weld from atmospheric contaminants that could cause weld defects such as porosity. TIG welding is considered the most challenging process of all, so there's more room for human error. Don't forget, safety is number one priority. You're working with blinding light, electrical currents, molten metal and hot sparks, so having the right safety gear is very important. This will include a welding helmet, a pair of TIG gloves, and a welding jacket. It's also a good idea if working in an indoor environment to use a respirator like this one to reduce inhaling welding fumes. We're going to break down TIG welding into 7 main categories for best explanation. These are what you need to start TIG welding, different types of TIG welding, torch setup, machine setup, how to TIG weld, other welding techniques, and extra accessories. Starting with what you need to TIG weld, you're going to need a few different components. First of all, a TIG welding machine, gas, tungsten electrodes, and fillet rods. There are many different types of TIG welding machines that you can TIG weld with. However, we'll break this down in the next section. The gas you will need, no matter what type of TIG welding you're doing, is pure argon gas, sometimes mixed with gases like helium to improve penetration. However, pure argon gas will cover almost every TIG application. Finally, you're going to need a tungsten electrode and a fillet metal. There's a bunch of different types, each with their own unique properties and characteristics. The different types of tungsten electrodes are the green tipped pure tungsten, which is fairly inexpensive but can only do AC welding. The red tipped thoriated tungsten, which is long lasting and easy to use, however can only do DC welding. The grey tipped serrated tungsten. These are DC and AC capable, however they don't perform well on high amps. A gold tipped lanthanated tungsten. These are DC and AC compatible, low burn off rate, easy arc starting and a great arc stability. These are our choice here at Unimig and they're a great place to start. A white tipped zirconiated tungsten. These have an extremely stable arc but are AC only. And finally, purple tipped rare earth tungstens. These are DC and AC compatible and can be used on high amps. However, depending on where they're made, the different materials used can give slightly different welding results. As our preference, we'll be using our gold tipped lanthanated tungstens for the rest of the video, and now it's time to show you how to prepare a tungsten electrode. There are 3 different ways to do this for different welding applications. Starting off with bald, which is done primarily for AC welding. This is a pretty easy shape to make, as you simply set your machine on high amps on AC, turn it on, and the tungsten will automatically form a ball on the tip over time. The next and most commonly used is pointed. This works well on DC and some AC applications and produces a focused and stable arc. To get this pointed shape, you will need a tungsten grinder or a bench grinder, and simply press your tungsten vertically to the grinder at a 30-degree angle and rotate at a consistent pace until a point has formed. Make sure to do this vertically, not horizontally, for better welding results. The final is truncated. This shape works well for both AC and DC applications and follows the same process as pointed. However, at the end of the process, you press the tip of the tungsten against the wheel to get a flat top. We'll be using the pointed variant for the rest of our video, as we find it's got the best arc characteristics and results in a more consistent weld. And now, onto fillet metals. As for fillet metals, otherwise known as TIG rods, are what you feed into your weld pool to complete a weld. You need to match your fillet metals with your parent metal, as the similar metals can only be welded with certain rods. Some classifications of fillet metals are mild steel rods, such as ER70S-2 is good for all grades of carbon steel, is pretty common in the industry. ER70S-4 for welding mild and high tensile steels, and they're also double deoxidized. And finally, ER70S-6 are an unalloyed rod used for general pipe steels. And now moving on to stainless rods. We first have the 308L, mainly used for austenitic stainless steels. The 309L, used for welding dissimilar metals. And finally, 316L, which is marine grade, recommended for use on anything that will be used in water and will only weld to 316 graded parent metal. And lastly, aluminium rods. There is 4043, which is used on 4000 to 6000 series aluminium and contains 5% silicon, and the 5356, which is used on 3000, 5000 and 6000 series of aluminium. It's marine grade and contains 5% magnesium. Now let's talk about the different types of TIG welding. The three different categories are high frequency, lift arc TIG and scratch start TIG. Scratch start TIG and lift arc TIG have very similar ignition and can be only used on DC. For scratch start, the way to ignite the arc is by striking the tungsten against the workpiece like a match. Pretty much the same as stick welding. And with lift arc, touch the tungsten to the metal and then lift it up to create the arc. Both these are very commonly found on multi-process welding machines and they're easy to operate. Just setting up your amps and away you go. These will also usually require a TIG torch that has a valve that is manually operated to release the gas. The next and the best thing for TIG welding is an AC/DC TIG welder, such as our 180 AC/DC or our 200 AC/DC. These machines have many parameters that can be adjusted and changed to suit your preference and the job you're doing. The way to use a high frequency torch is by simply holding the tungsten 3mm away from the joint, pressing the button after your parameters have been set, and off you go. We'll talk about the actual technique further in the video. To set up a TIG torch, you'll need some consumables. With each torch they will range in size, shape and setup, and these will usually include a head gasket, a heat zone isolator, a gas lens and collet, a back cap, a shroud, and a tungsten. To put them on a TIG torch, we'll be using our T2 torch as an example. You'll need to slide on the head gasket, screw on the heat zone isolator, push in the gas lens and collet, screw on the back cap, slide in the tungsten, and push on the shroud. You can also set up remote mode on an AC/DC machine for use with the optional foot control or the torch control. To do this, hold the button for 5 seconds or until the machine beeps and the green light comes on. Then you're able to change the amps using the optional foot control or the torch amperage control. And now we'll move on to machine setup for scratch start and lift arc TIG. Starting off, plug your machine in and turn it on. You'll then need to attach your flow meter regulator onto the gas bottle. Next, you'll need to plug your torch into the negative panel mount. Attach the torch gas hose into the flow meter regulator. And then put your earth clamp into the positive panel mount socket. Now you just need to set your amps, turn the gas onto about 8 or 10 litres a minute, and you're ready to weld. And now we'll move on to machine setup for high frequency TIG. Starting off, let's plug our machine in and turn it on. Next, attach your earth clamp into the positive panel mount socket. Then you'll need to plug your high frequency torch into the negative panel mount. Attach the power cable plug into the socket and the gas hose into the gas connector at the front of the machine. Now it's time to attach your flow meter regulator to your gas bottle. and tighten it with a spanner. Now connect it to your machine using the supplied gas hose. Make sure to crimp it tight or use a quick connect adapter. And now it's time to set up the parameters for this machine. If it looks too complicated, don't stress. We'll run you through everything you need to know about each setting and what it does. Starting off, there are 5 red lights with the following options. These are AC, AC pulse, DC, DC pulse, and finally MMA. You'll need to choose the correct one for your welding process. Alternating current, otherwise known as AC, is used for welding aluminium, whereas DC, direct current, is used for welding steels and stainless steels. The AC and DC settings will provide a constant running current, while the pulse options will give you a pulsating current. The pulse options are often used for very precise or artistic welds on thinner materials, as it does not penetrate as deep. You can then choose between 2T, 4T and spot. 2T means you need to retain pressure on the trigger while welding. 4T, which means after you press the trigger, the arc will continue on its own until the trigger is pressed again. And finally, spot, which will give you consecutive and evenly timed tacks. We'll be using 2T for the purpose of this demonstration. And now, it's time to move on to parameters and what they adjust. We're going to start off with pre-gas. Pre-gas is a gas that shields the tungsten and the area you're about to weld from the atmosphere. Use the knob to select how long you'd like your pre-gas to flow before your arc ignites. Start amps allow for a lower or higher amp start, depending on the material. If you have a thicker piece of metal, you want to start on higher amps, and if you have a thinner piece of metal, you want to start on lower amps. Upslope will dictate the amount of time in seconds it will take to reach your peak amps from the start amps. The more time you input, the longer it will take for the amps to increase. A longer upslope is recommended for thinner materials to prevent burning straight through. Peak amps are the amps that you'll be welding until you have finished your joint. If you are set on AC/DC pulse, this will be a high part of your amp cycle. Base amps are only used in pulse modes. This is the low part of your amp cycle. The closer your amp range from peak to base, for example 80 peak, 70 base, the hotter your weld will be. The more significant the gap, for example 100 peak, 70 base, the cooler your weld will be. AC hertz is the times per second that the current completes a full cycle. If you turn this up, it will increase the cycle speed and create a thinner, more prominent weld appearance as the arc will be more focused. The lower you turn this, the flatter your weld will be, and it's only for AC and AC pulse. AC balance is automatically calibrated based on your other parameters. However, you can manually adjust it. If you set it to above 0, you'll increase the cleaning and decrease the penetration, and if you set it below 0, you'll decrease the cleaning and increase the penetration of the weld. Once again, it's only for AC and AC pulse. Pulse hertz is the number of times per second that the current cycle will switch between peak amps and base amps. The faster the amp switches, the narrower the weld. This is for AC/DC pulse only. The pulse percentage is the percentage of time that the peak amps are on during the pulse cycle. A high percentage will have a hotter weld and a low percentage will have a cooler weld. Once again, it's for AC/DC pulse only. Downslope will dictate the time in seconds between the peak amps and your finish amps. This will taper the arc to prevent crater holes and cracks in the weld. Finish amps is the final amp level that your machine will reach before the arc extinguishes. If you turn it up, it will be a hotter finish suited for thicker materials. Turning it down will provide a cooler finish suited for thinner materials. And finally, post-gas. This is the gas that flows for a set amount of time after the arc is turned off, to shield and cool the tungsten as well as the weld. The longer you leave this on, the less likely you're going to have pinholes and craters. The thinner the metal, the less time it needs to be on. You will now need to pick the size of your tungsten electrode. Input the tungsten size into this program, but keep in mind that the machine will only provide a limited number of options as there are only so many tungsten sizes. So now that all this information is out of the way, it's time to teach you how to TIG weld. We'll be showing you the proper technique on downhand, horizontal, vertical and also overhead, but firstly you must make sure that your metal is clean. With ferrous metals such as stainless steel or mild steel, you need to take it back to bare metal using a grinder. With aluminium, make sure to clean it with some acetone and a clean rag. The main factors to consider when you're TIG welding is travel angle, travel speed, distance and consistent rod dabbing. A few consistent techniques that will be used for all these positions is that you must always push the torch and not drag it. Dragging or pulling while TIG welding won't penetrate, resulting in porosity in the joint as the gas from the cup won't reach the liquefied metal. You also want to keep your torch at a 10 to 15 degree travel angle as you push on the butt weld, and also the same angle when you're doing a fillet weld for the best gas coverage. Make sure your fillet metal comes in relatively low, almost parallel with the joint with a slight 10 to 15 degree angle. The best length to keep your tungsten from the workpiece is around 3mm. This will give you the best control over the arc in your weld. It also gives you space so that the fillet rod is unlikely to touch the tungsten. Make sure to resharpen it if it goes blunt or the fillet rod comes into contact with it. And finally, at the end of the weld, make sure to leave your torch there for a second to get the adequate gas flow over the weld so you don't leave any welding defects. One easy way to know if you're welding with the wrong technique is that your bead appearance through your lens will not look consecutive. This is due to the wrong torch angle, traveling at an inconsistent speed, and with the wrong torch distance. This will end up with a weld that looks like this. For a flat butt weld, angle your torch like this. Travel at a steady consistent speed and make sure to add plenty of fillet rod. You should end up with a weld that looks like this. Now let's move on to a horizontal butt weld. Making sure to angle your torch like this, travel at a steady consistent speed, and make sure to add plenty of fillet rod. you should end up with a weld that looks like this. For an overhead fillet weld, we recommend dropping your amps by about 5 compared to a flat butt weld due to you now working against gravity. Making sure to still angle your torch like this. Travel at a steady speed and make sure to add plenty of fillet rod. You should end up with a weld that looks like this. For a vertical fillet weld, we recommend keeping similar amps to that of an overhead weld as you are working against gravity once again. Making sure to angle your torch like this, travel at a steady consistent speed and make sure to add plenty of fillet rod. And once again, you should end up with a weld that looks like this. As a final note, these techniques will work for AC and DC. The only difference is your tungsten preparation. Now let's move on to other TIG welding processes such as mixed arc AC/DC and fusion welding. Starting with mixed arc AC/DC welding, this is a combination of TIG AC and TIG DC negative in one weld. There are quite a few benefits from this type of weld, including high welding speeds and penetration and a faster weld puddle on cold workpieces. Mixed AC/DC also means that you can weld on thicker materials. There are two periods during a mixed weld. The first is the AC period, where the oxide film is broken and the surface impurities are flushed out, and the second, the DC minus period, where the arc becomes narrower and penetrative. The operator can select a percentage of AC and DC minus during a full period, which can be varied from 5 to 95%, though it's a good idea to have more than 50% DC minus. This feature is pretty specialised and is meant for advanced welders. Our Razor 320 AC/DC is the only welder at the moment that carries these capabilities. Fusion welding follows the same process as normal TIG welding, but with no added filler wire. This is nowhere near as strong as a standard weld, and so it's best for use for practice only, or used to quickly tack metal together for a proper weld. Finally, it's time to talk about some accessories that will help you while TIG welding, starting off with gas lenses and clear quartz cups. Standard nozzles release a broad plume of shielding gas over your weld. In comparison, a gas lens in a clear quartz cup improves the shielding gas coverage by distributing gas all around the tungsten more effectively with less turbulence. You can also have the tungsten stick out further with a gas lens, giving you more manoeuvrability and visibility of the whirlpool. Another great accessory for taking your TIG welding to the next level is a foot control. This works in conjunction with the TIG modes on your AC/DC machine and gives you greater control over amperage control when welding, making sure to have your machine in 2T for this accessory to work properly. To operate, simply connect it as instructed before and place it on the floor. You will then need to use your foot similar to the accelerator pedal in your car. With the further you push down, the higher the amps will go in the amperage cycle that you have chosen, and the more you release your foot, the lower the amps will go. Right angle magnets are also a perfect accessory for all kinds of welding. These help keep the pieces of metal in place while taking or welding. However, these do not work on aluminium, so you'll have to use a normal clamp. Finally, having acetone and a clean rag on hand to clean your aluminium before welding is a must and worth the small investment. Thanks for watching our ultimate TIG welding guide. If you like what you saw, don't forget to like the video, and we'll see you soon.